Let's take a look at this problem. We got A is equal to 1 million. R is 10.5%, so 0.105 in decimal form. And T is 40. And it says fill in the following table. First four gives us in values. So we want to use this formula. A is equal to P. I wrote down the wrong one. Try it again. A is equal to P times 1 plus R over N to the NT power. Now I want to get P by itself, so we divide both sides by what's behind our P. So we got A divided by 1 plus R over N to the NT power is equal to P times 1 plus R over N to the NT power divided by 1 plus R over N to the NT power. These 1 plus R over N to the NT powers cancel. And we got P is equal to, let me put it down here, P is equal to A divided by 1, try it again, 1 plus R over N to the NT power. That's the formula we're going to be working with on these first four. Okay, so first one says N is equal to 1. So plug it into our formula, everything we're given. A is equal to, or P is equal to A, which is 1 million, divided by 1 plus R, which is 0.105, divided by N, which is 1, raised to NT power, which would be 1 times 40. And that's going to give us 1 million divided by 1 plus 0.105 raised to the 1 times 40, or 40th power. So let's plug that in. We got 1 million divided by, beginning parentheses, 1 plus 0.105, close parentheses, caret 40. So this is $18,429.30. Assuming you could get an interest rate that high, if you compounded one time per year, if you left it in it for 40 years, you put $18,429.30 into the account, left it for 40 years, at the end you'd have $1 million. It's kind of cool. Let's do the next one. N is equal to 4. Same formula. So P is equal to 1 million divided by 1 plus 0.105 divided by N, which is 4, raised to the NT power, so 4 times 40. That gives us 1 million divided by 1 plus 0.105 divided by 4, raised to 4 times 40 is 160 power. So we got 1 million divided by, beginning parentheses, 1 plus 0.105 divided by 4, close parentheses, caret 160 power, enter, and we get $15,830.43. Okay. Next one's N is equal to 12. Plug in the same formula. So we got P is equal to 1 million divided by, beginning parentheses, 1 plus R, which R was 0.105, divide by n, which in this problem is 12, raised to the 12 times t. What was t? T was 40. Okay, so that gives us 1 million divided by 1 plus 0.105 divided by 12 raised to the 480 power. So let's see, we got 1 million divided by, beginning parentheses, 1 plus 0.105 divided by 12, close parentheses, caret 480. And that gives us $15,272.04. The next one is n is equal to 365. Plug into the same formula, this one here. So we've got 1 million divided by 1 plus r, which is 0.105, divided by n, which is 365, raised to nt power, which is 365 times 40. Now this one I'll type in as I see it, and I want to be sure to put parentheses around the exponent like that. So let's see what we get. 1 million divided by, beginning parentheses, 1 plus 0.105 divided by 365, close parentheses, caret, beginning parentheses on the exponent, 365 times 40. So 365 times 40, closing parentheses, enter. And that gives us $15,004.64. Okay, so we got A is equal to 1 million. R is equal to 10.5%, or in decimal form, 0.105. Time is 40 years. This next part is asking us about continuous compounding. So that would be our PERT formula. So we got A is equal to P e to the RT. We want to get P by itself, so we divide both sides by e to the RT. We're going to do that. These e to the RT's cancel. And we got P is equal to A over e to the RT. Now that's our formula we're going to use. So we'll plug in the numbers we just wrote down. We said A was 1 million, so I got 1 million divided by e to the RT. R is 0.105 times t, which is 40. When you plug this in, you don't want to put any extra parentheses in. So we'll do 1 million divided by e, which is second ln, second natural log. It puts e, puts a caret, puts a beginning parentheses. Now we're going to put in 0.105 times 40. Enter. And that gives us $14,995.58. And that's our answer.